So that's working with the bitmap directly. Let's talk a little bit about color. Color is a very big topic in processing. We have basically grayscale colors, which are 0 to 255. So if you just say color 150, you're getting a grayscale color where actually the red, green, and blue values are all set to 150, and that gives you a gray color of somewhere in the middle. And 255 is of course white, and 0 is black. 150 is halfway in the middle, or 128 is halfway in the middle, and we can give ourselves different variations of grayscale colors that way. We can also make a color with a red, green, and blue set all to the same value, or even to close values, and we'll end up with a gray. Now, we can also do red, green, and blue colors by specifying each of the colors individually, 1, 2, 3, and also alpha if we want to. Alpha is transparency, again. And we can specify it with values from 0 to 255. Now, hue, saturation, and value, this is a different way of specifying colors. Hue is the type of color, so red, green, blue, that type of thing. And we have a ring of colors from 0 to 255, and they're all different colors. Saturation is the strength of that color, and value is the brightness of the color. So if you put the value up high, you'll get very bright colors. So that's quite a different set of numbers to use to red, green, and blue, because specifying a color with red, green, and blue takes a bit of, it's a bit tricky. You have to say how much green there is in a mostly red color or something like that, and that's quite hard to get right unless you've got the color values given to you already. Whereas hue, saturation, and value, you choose a specific color and then you control its saturation and its brightness specifically. Now, HSV is also called HSB sometimes for hue, saturation, and brightness. Now, a little bit of a coding thing. So in computing, we often need to work with lists and arrays. You've seen before. Arrays are important. I'll just mention this one more time. We're going to be using arrays to deal with pixels directly. So if we want to work with 5 student marks, just like we said before, we could write out each of the variables one by one, but that doesn't work very well for 5 different marks. Imagine if you had 2 million pixels to work with, which you'll see we do actually have. We couldn't possibly deal with 2 million pixels as separate variables. It would not be possible. So we have arrays. Here we have the way that we can write an array for those marks. We say new int 5, and that gives us 5 positions in an array, and we can put marks into those positions. And you can see 0, 1, 2, 3, 4 for 82, 75, 14, 99, and 52. So that makes it a little bit more neat, and we're only dealing with one variable. Here we have initialization of an array with a loop, and in a similar way you can initialize an array by looking into the window. The pixel buffer itself is actually an array, and it's a one-dimensional array. We'll come to that in a second. But you can have a look here. If you do this thing where you call load pixels with nothing as an argument, that will load the pixels in the window and put them into an array called pixels. So it doesn't actually require you to say pixels equals load pixels. You just say load pixels. There's only one pixels array, and it's reloaded every time you call load pixels. Now you can set the pixels value to whatever you want, whatever color you want, and then you can say update pixels to have a look at what you're going to get. So I'll have a look at that very quickly. Pixel buffer simple. Now this is a very small example, and you probably can't see it, but this is a pixel buffer. I might make this 0, it might be more easily seen. There you go, you got a little black dot there. Pixels 24, well, how many does this, how big is this? It's, it defaults to, I forget exactly what it defaults to. Let's set it specifically, shall we? Size 100, come on, 100. That'll be even smaller, I think. That seems to work. Yeah, okay, so it's 100 by 100. We load the pixels, and the 24th pixel is appropriately about a quarter of way long. Now, think about how many pixels are actually in this buffer. It would be 100 pixels across by 100 pixels down, so that'd be 10,000 pixels. Can we set the 10,000th pixel? Well, no, we can only set the 9,999th pixel because there's 10,000 pixels, but 0 is the first one, so we can't put the can't change that value. But the 9,999th pixel is the dot in the bottom right-hand corner there. So we are able to set pixels very, very simply just by using load pixels. This pixels array here, which is automatically generated when we do the load pixels command, and update pixels to change that back in the screen. That's pretty interesting. Now, for performance reasons, processing's pixel buffer is a one-dimensional array. So instead of us having an X value and a Y value, you could do that. You could have a pixels array that was 2 dimensions, but it's a bit harder to do that, and it's slower. So instead of doing that, we just have a really long list of pixels, and we wrap them around to make an image. So here's an example of wrapping around. We start with A, B, C, D, E, F, G, H, I, J, K, L. So we've got 4 pixels along the x-axis and 3 pixels along the y-axis. And instead we just make it a 12-element array, and we go A, B, C, D, E, F, G, H, I, J, K, L along that way. So an example here is the white line code. So that makes a white line, not surprisingly. Here you can see we set it with the 500 times 500, and we load the pixels, and then we set all pixels that are height divided by 2 times width plus x to white. So that's height divided by 2, which is 250, times width, which is 500, 250 times 500, plus x. So fiddle around with that and see whether you can move that white line around by adding or subtracting an offset, for instance. And that's just basically doing the same thing we did with the simple pixel buffer, with a bit more, with a larger buffer and more pixels being changed. So for many operations, you don't really need to worry about X and Y coordinates. For instance, color changes which affect an entire image. So here we want to just add values to all of the pixels or change all of the pixels. So let's have a look at black and white. So in this case, we're loading a picture, setting it to the side, setting the window to the right size, and then we're loading the pixel buffer. We're getting the color out, and we're setting the color to 0.299 times the color plus the green value times a certain weighting plus the blue value times a certain weighting. But that's all getting added up into a single value, which is being passed to the color command. And you remember, a single value is a gray color. So we're adding a little bit of the red, a little bit of the green, a little bit of the blue together, mostly the green, and then a good proportion of red and a little bit of blue. And we're ending up with a number that is between 0 and 255, and we're going to end up with a color from that. So then we put that into the pixels array. We're working all the way through the whole pixel array here. See, that's pixels.length for that for loop. And we update the pixels, and bam, we have a black and white image now instead of a color image. So we've taken our color image, we've extracted the red, green, and blue values and added them all up and kind of taken a bit of an average and ended up with a, for each of the pixels, an average value for each of the pixels. And we've ended up with a black and white picture. Now we could mess around with these values here and see if that changes the type of picture we end up with. And I think we would end up with slightly different tones in the grays, but we're always going to be getting grays because that's what we ask for. Similarly, if we have a look at black and white 2, let's see what this one does. Here we're loading an image directly, and we're loading the pixels for the image from the image, and then we're setting the pixels in the image directly, and we're updating the pixels. So it's a slightly different thing, but still we're turning things black and white. But this is just for an image, so you can control the pixels of an image directly and then draw that image onto the screen. You don't just need to load pixels for the whole window. You can load pixels for an image, which gives you a lot of power as well because you can have multiple images. Finally, sepia. Let's have a look at that one. That's going to turn things into a sepia tone, of course. And there we go. So sepia tone is a little bit different. We have to have red, green, and blue. And then we set the pixel values with this new color where we've weighted the red, green, and blue values differently to give that sepia tone. So you could change those numbers and give it a blue hue, for instance, or a redder hue, up to you. Sepia tone is just a particular shade of color. Okay, so hopefully you now understand the concept of bitmapped images, and you're able to load, display, and manipulate images in processing, and understand arrays and how they relate to images. So this is really important because not only will we use images just in our processing sketches directly, but as we start to work with video, you'll see that video is just made up of images that change all the time, and we can deal with video in a very similar way to dealing with images. So that's quite important. Anyway, good luck, enjoy this week's lab, and talk to you soon.